Hello, Math 7 students. We are now starting lesson number 8, video number 8. So we're turning in our table of contents to video number 8. And video number 8 is interpreting graphs of proportional relationships. And we can find that in my comp book on page 23. So I'm going to turn there now. Page 23 is right here. Okay. And so, again, the name of our lesson is Interpreting Graphs of Proportional Relationships. So obviously we're going to be working with graphs, and we're also going to be looking at the graphs to figure out if the relationship is proportional. Our goal for today, we will use all of the information we have learned to interpret graphs of proportional relationships. The question that I want you to be thinking about during this lesson is, what points are always on the graph of two quantities that are proportional to each other? What points? Okay, there are 2 points that you will always find on a proportional graph. Your job is to figure out what those 2 points are during today's lesson. All right, so the task that we're going to be working with is kind of fun. It is called Grandma's Special Chocolate Chip Cookie Recipe. Okay, and the thing that's fun about this is it tells us exactly how much we need in order for us to know what we need to have in order to make her recipe of the chocolate chip cookies. Sorry, I'm trying to make this a little brighter for you so you can see it better. Hopefully that works. Okay, so Grandma's Special Chocolate Chip Cookie Recipe, which yields. Yields means makes. So whenever you're reading a recipe and if it says yields on it, what it's telling you is that's the number that it makes. So Grandma's Special Chocolate Chip Cookie Recipe, which yields 4 dozen cookies. So when you make the cookie dough, you're going to be able to make 4 dozen cookies. And remember, a dozen is 12. So if you have 4 pans of 12 cookies, that means that you have 48 cookies, right? It calls for, in order to make those 48 cookies, 3 cups of flour. Okay, so if you don't have 3 cups of flour, you're not going to be able to make all of these cookies. Okay, so the way that we're going to figure out if this task is proportional is we're learning a new chart. And boys and girls, you're going to make a poster of this in a couple of days, and this chart is actually really cool. It works with any problem that you're trying to decide if it's proportional or not. So it's called the proportional chart. And it actually has 6 sections. So you basically just draw a rectangle and you divide it in half, and then you take those that are in half and divide it into thirds. And what we see is in the first box of your chart, you need to put a ratio table. In the second box of your chart, you have to answer the question if this table is proportional or not. In the third box, if it's proportional, you should be able to find a unit rate. And then when you get done with that, you have to come down here to this box and make a graph that supports it. If the graph is proportional, this is what the box that you use. And then lastly, you need to be able to write an equation that represents the proportional relationship of your chart. And so that's what I'm going to show you that we're going to use to work on with this Grandma's Special Chocolate Chip Cookie Recipe. So first thing we have to decide is because they're truly, well, yes, there is an independent. Which one? Let's look up here. We're trying to make cookies by using flour. So what depends on what? I'm thinking if you don't have the flour, can you make any cookies? The answer is no. If you don't have flour, you can't have cookies. So I'm going to say the cookies depend on the flour. So the independent on this one is going to be the flour. Because if we don't put the flour in the cookie dough, does the flour still exist? Yes. Do the cookies exist without the flour? No. Okay, so flour is the independent. Cookies are the dependent. So we just identified the X and the Y value, yes or no. The flour is the X. The cookies are the Y. Okay, remember that. You're going to need that for this box down here. Okay, so what we know is it takes 3 cups of flour, so 3 cups of flour for 4 dozen cookies. Now, there's 2 ways that we can think about this. We can write the ratio talking about 4 dozen, or we can write the ratio talking about the actual number of cookies. since we're trying to use the quantities from the task, I would like you to stick with dozens. So 3 cups of flour makes 4 dozen cookies. Okay? What happens if I try to find, if we double it? Double it means that you are going to do it 2 times. So how many cups of flour are you going to measure out if you're doing it 2 times? The answer is 6. So we have 6 cups of flour. How did we do that? We went 3 times 2 and we got 6. So what you do to one side, you have to do to the other. 4 times 2 equals 8. So that means that for 6 cups of flour, we can make 8 dozen cookies. Well, boys and girls, what if we only have, let's say we're scraping the bottom of our bag of flour and only 1 cup comes out. So how do we figure out how many dozens cookies we can make if we only have 1 cup? So the question is, how did you get from 3 down to 1? So if I'm hearing you correctly, I'm thinking you're saying 3 divided by 3 equals 1. So you have to say what you do to one side, you have to do to the other. So 4 divided by 3, we're going to write it as a fraction first so we can see it. 4 divided by 3 would look like that, which is just says 4/3, okay? And if we went ahead and simplified that out, we know that 4/3 equals 3 can go into 4 one whole time with 1 left over. So it would be 1 1/3 dozen, okay? Now you got to remember that these are dozens. They're not the actual cookies themselves. Okay, so now we have a ratio table. The next step is to figure out if the table is proportional. Do you remember how to do that? I think you do. We've done it many times. So you're going to write 3 times what number gives me 4. Okay? Then you're going to write 6 times what number gives me 8. Okay? And then you're going to write 1 times what number equals 1 1/3. Okay? And that's what you're going to do to figure all of these out. So let's do some math. I'm going to do math on a separate sheet of paper so you can see it. So 3 times what number gives me 4? I have no idea. But we do know that we could take 4 divided by 3 in order to figure that out. So 3 goes into 4 one time with 1 left over. So I got 3 times 1 1/3 sits on that line. Let's see if it works for the next one. The next one says 8 divided by 6 because 6 times what number gives me 8? 6 goes into 8 one time. 2 leftovers, which is 2/6, which equals the same thing as 1 1/3. Oh, so far so good. Okay, last one. Let's check it. 1 1/3, which is 3, 4, 4/3, divided by 1. What is 4/3 divided by 1, everybody? 4/3. And what is 4/3 the same as? 1 1/3. So did we find it? The answer is yes. So 3 times 1 1/3, 6 times 1 1/3, and 1 times 1 1/3. So is the table proportional? The answer is, put a little box right here, yes. Okay, so going back to our ratio table, did we find our unit rate? Remember, a unit rate is per 1. So is this per 1 right here? The answer is yes. So how many dozens of cookies per 1 cup of flour? The unit rate is M equals 1 1/3. Okay? Boys and girls, are you starting to understand this? Is it making more sense to you? I hope so. Now we have to graph it. Okay? The way we graph it is, remember, this is the x-axis and this is the y-axis. We decided that flour was the independent and cookies, dozens of cookies, was the dependent. So the x should be flour, so you're going to write flour on the bottom. And then you are going to write cookies on the side. And we'll put dozens in the parentheses. Okay? So we know that for every 1 cup of flour, there are 1 1/3. So we're going to say 1 is about here, so 1 1/3 would be about here. Okay? And then for every 3, so this is a 1 right here. This is a 1 right here. Then this would be 2, 3, 4, 5, 6, 7. Okay? And we'll say 2, 3, 4, 5, 6. Okay? And so this is a 2, this is a 3, this is a 4, this is a 5, this is a 6. This is a 2, this is a 3, this is a 4, this is a 5, this is a 6, that's a 7, okay? And now we're going to plot all of the rest of what we have so you can see it. So the next one we have is 3, 4, so I go to the right 3 and up to 4, which happens to be about here, okay? And then we have 6 to 8, which would be clear up at 6, 7, so we would say it's about here. Okay, the only one that we forgot to talk about was, boys and girls, what happens if you have 0 cups of flour? How many dozens of cookies get made? That's right, 0. So 0, 0, because if you have 0 cups of flour, then you have 0 cups of cookies being made. All right, so that looks like a pretty good graph, okay? And then what we have to do is we have to draw a line through it because it's straight. As long as it's straight, you draw a line through it. And now there are 3 things that we have to check to see if this is a proportional relationship. The first one, who remembers? You are correct. It has to go through the origin. Nice job. Okay, what is another one? You are correct. It has to have a constant. And what is the last one? You are correct. It has to be a straight line. In order for the relationship to be proportional, the line has to be straight. Okay, so let's go to our graph. Did it start in the origin? Yes. 0 cups of flour makes 0 cookies. Okay, does it have a constant? Oh, well, we already know from our unit rate, because remember, the unit rate is the exact same thing as the constant. Did we find a constant for all of the points? Yes. So there is a constant, 1 1/3. And looking at our graph, does it form a straight line? The answer is yes. So far, so good. All right, kiddos, so we're on the last section of the chart. And there's this really cool equation that I taught you in the last lesson. Who remembers it? That is right. Y equals M times X. Do you know what the M is? Yes, it's right there. So now we get to write an equation for this. So our equation for this specific chart about Grandma's special chocolate chip cookie recipe is Y equals 1 1/3 times any value of X. That's the equation that you have to write. And that's the whole chart, you guys. That's how easy it is. Okay? The chart is very, very helpful because it helps you figure out if the relationship is proportional, and this one is proportional. So nice job. Okay? Hoping you're feeling pretty comfortable with this. Let's keep going to see what we're going to work on next. All right? So the next thing that we need to talk about before we're finished with our lesson, remember when you're starting a new page, please put your title up at the top, Interpreting Graphs of Proportional Relationships. There's some follow-up questions that I want to ask you from the little chart that we did on the other page. It says, on the graph, what do the ordered pairs represent? Okay, on the graph, what do the ordered pairs represent? So let's go back and look at it. What does 0, 0 on this graph right here represent? That is correct, the origin. What is another name for the origin? A point, a plotted point. Okay, 2, 3. Did we do that one? No, we did a different one. So if we had 2, 3, then it would have been plotted that way. So what can we conclude from all of these points from a different graph? What could we say ordered pairs represent on a graph? What do they represent? The answer is individual points on the graph. So ordered pairs are the actual points, the dots on the graph. Okay, so hopefully you know that. How do you find the unit rate on the graph? Well, we did that. If you go back to our graph from our grandma story, let's look on here. The unit rate is always, and boys and girls, this is not a trick question. You need to know this. The unit rate, listen very carefully, the unit rate is found by finding 1 on the x-axis. This is the x-axis. So whatever point lies on your 1, that answer up there is the unit rate. So since we went to 1, what number did we also go to? 1 1/3. So we know whenever we can locate 1 on a graph, wherever we go, that's the unit rate. So we go to 1, we go up to 1 1/3, so my unit rate is 1 1/3. You got to remember that. So on the graph right here, how do you define or identify the unit rate on a graph? What I want you to put right here is always look at the 1 on the x-axis. Write that right now. Always look at the 1 on the x-axis. Okay? All right, the next question that we need to answer is, what quantity is represented by the horizontal axis? What quantity is represented by the horizontal axis? Well, if we look down here, what quantity was represented down there? It was called flour in our example, but what do we call that all the time? The independent value. Everybody say independent value, okay? So the horizontal axis has the independent value. Well, if the horizontal axis has the independent value, what quantity is represented by the vertical axis? Always the dependent value, okay? The y-axis is the dependent value. The x-axis is the independent value. You've got to remember that forever, okay? What does 2 in the ordered pair up there stand for? Okay, it says what does 2 in the ordered pair 2, 3 mean? That means that there are 2 independent values. So you're on the 2 on the horizontal. What does the 3 in the ordered pair mean? That means that you go up 3 on the vertical. Okay, so to the right 2 on the horizontal, up 3 on the vertical. Okay, and then really fast, because you already could figure this out, what is the unit rate? Let's use this number right here. So what you're going to do is you're going to take your little chart. We have new numbers because of the sides, so x and y. You had 0, 0, you had 2, 3, okay? Then you had 4, 6. So now let's figure out what 1 would be. So how did we get from 2 down to 1? That's correct. You divide by 2. What you do to one side, you have to do to the other. So 2 divided by 2 is 1. 3 divided by 2 is exactly that, 3/2. If we simplify that, 2 go into 3 one time with 1 left over. So we know the unit rate for this one would be 1 1/2. Okay? All right, you answered all the questions. I'm very proud of you. Turn back and let's look at our question for the lesson. Our question for the lesson was, what points, so there's more than one, what points are always on the graph of 2 quantities that are proportional to each other? And they will be every scenario that you do. Let's look very carefully. I will try to point to the answer. What 2 points, let me make it bigger so you can see it. What 2 points are always on every single graph, no matter what relationship you're working on? Will have to give me that answer tomorrow. All right. Have a good one.